All right, I'm back. Not much left. So a graph is shown there. This is the velocity graph. When is it at rest? So think, when is it at rest? When it's equal to 0, right? So at what time is it 0? And the answer is 5. Part B. Find the acceleration at 2. So here's 2. Acceleration is the derivative, the slope. So what's the slope at 2? Well, that slope is 0. It's horizontal. So a at 2 is equal to 0. For 3, here's 3. What's the slope at 3? So you go, I need 2 points here. Go down 1, 2, 3, 1, 2. So negative 3 over 2. And what was the last one? 5. Oh, wait a second. I skipped 3. I went to 5. That was 5. 3. At 3, it doesn't exist. So why doesn't it exist? So at 3, the left does not agree with the right. So approaching from the left, it's 0, and then it's negative 3 over 2 there. So the left and the right do not agree. That corner there, the derivative doesn't exist at a corner. So the answer is it doesn't exist. That's 5. That's 3, just so you know. Part C. Find the total distance traveled from 0 to 7. So when you're given velocity, you're integrating for total distance, and it's just the area from 0 to 7. And so I'm going to find the area here. That's a trapezoid. And I'm going to find the area here. That's a triangle. And total distance means all the areas are positive. So trapezoid, that's 1/2. One base is 5. The other base is 3. And then the height of it is 30. So know the scale. And then here, the triangle, half, the base is 2. And then the height is, I'm going to rate a positive number again, is 30 for the height. And so calculate that. We actually don't need to simplify it if we don't want to. But if you did simplify it, the answer would be 100 and, what would it be? 150. And it's in feet per second. So the answer is feet. This one I should put units to. This is feet per second squared. This is feet per second squared, right? And this should be seconds. So at 5 seconds, it's at rest. Shame on me. Recognize if there's units involved. Part D. At what time is the velocity 10? So I see the velocity is 10 right here, and at what time? So it's right here. I'm not going to guess what that is. So I need the equation of that line. All I need to know is a point, and I got a point, 5, 0, and the slope, which is negative 3 over 2, and I can write an equation. So negative 3 over 2, I'm going to use x. We can use t. T minus 5 plus 0. I don't need the plus 0 here. So just an equation of a line. And then I'm going to make it equal to 10, and I'm going to solve it. So I'm going to multiply by negative 2/3 to the reciprocal. That's negative 20 over 3. And then I'm going to add 5 to that to get t by itself. And that's a good answer. If you wanted to, you could multiply by 3, and then it would be, what did I do? Oh, you know what I did wrong? The slope is wrong. Because I didn't do the scale. So when I should have done the scale, I should have went negative 30 over 2. Negative 30 over 2. Did you catch that mistake? I bet you did because you're smart. So negative 30. Negative 30. In other words, negative 15. So let's try this again. So this slope is actually negative 15. So no, no, no. So the equation then would be negative 15. And the point again is that one was right. Again, you could use t if you want. And then make it equal to 10, and then solve it. That's going to be much better. So divide by negative 15, and then add 5. Now it's going to be a positive answer. I didn't like that it wasn't positive before. And again, if you solve this, common denominator, 75, that's 65 over 15. At that time, it's 10. All right. It says give a piecewise function for the velocity. So if I think of the velocity as two pieces, the first piece is here at 30, just 30, a horizontal line, and it's 30 from 0 to 3. And then the second piece, we just did an equational line. That was negative 15. We're going to use t. And that's t minus 5, and that's from when t is greater than or from 3 to 7. Next, if the position of the particle at time 0 is 4 feet, find the position of the particle in 7 seconds. So this is a starting value question. So it's starting at 4, and then we add the answer to the integration from 0 to 7 of the velocity. So in other words, we go 4 plus the answer we got at the very beginning, which was, oh, you know what? But this one we need positive and negative. So the positive part was 1/2 5 plus 3 times 30. So that's this part. Down here now, because it's not total distance, this is going to be negative. So then we subtract the triangle, and that would be the answer. Now, if you simplified that, and you don't, you could just go like this and say feet, and you get full credit. But if you did want to simplify it, it would be 94 feet. But this would give you full credit with feet at the end. All right, last question. A particle moves along the x-axis in such a way, again, that its acceleration is given by this. So I'm going to write that down. The acceleration is 3 over t squared, and I feel like I want to write it in calculus friendly already. When t equals 1, the position is 6, and its velocity at 1 is 2. And then it says answers. Write an equation for the velocity. Write it for the position. So for the velocity, we are going to integrate this. That's why we wrote it friendly. We're going to add 1 to the exponent and divide plus c. And then we're going to plug in. So there's the velocity. We're going to plug in 1 for t and make it equal to 2. So we make it equal to 2, plug in 1, and then solve it. Remember, 1 to any exponent is 1, so this is just negative 3. So add 3, and c is equal to 5. Put it all together, and the velocity is, for c equaling 5, so just write that down. Now for part B, how do you find the position? Again, we integrate this. So we're going to add 1 to the exponent. Now, for this one, what happens when you add 1? So this actually is going to be a logarithm. So let's write it so you can see the logarithm. So the derivative of the bottom matches the top. So the derivative of the bottom is 1, which is like terms to the top. This, you can't add 1 and have 0 divided by 0. This is going to be a logarithm. It's going to be negative 3 and the logarithm of t and then 5 will be 5t plus c, and then plug in, what does it say? Plug in 1 and equal to 6. So we're going to plug in 1. Ln 1 is 0. We need to remember that. So what we have is 5. So subtract 5, and c is equal to 1. And so the position equation is negative 3 ln t plus 5t plus 1. And then the question is, the last one, find the position of the particle when t equals e. All right, so ln e is equal to 1. So this is just negative 3 plus 1. So that means it's 5e take away 2. That's it. Mr. G Math over and out. Great job reviewing with me. Until next time.